We're going to be solving problem 3.69. The problem involves a form in concrete. So there's cured concrete down here, and a form is attached to the cured concrete with two bolts. And we're going to make a new pour. So we're going to pour concrete to a depth of y1 equals 1.5 meters, and the form's at a 60-degree angle. The goal here is to find the moment at the base of form per meter of length into the paper. We know the specific weight of concrete is about 2.5 times the specific weight of water. And just to make the problem easy, we're going to assume that the form has a length of W equals 1 meter into the paper, and we're going to neglect the weight of the form. So again, our goal is the moment right here at the base. Let's look at ideas to reach the goal. There's three ideas we need to solve, use to solve for this problem. The first idea is the panel force equation. This is a sketch of the panel. Here's the centroid of area. We know that the hydrostatic force acts at the center of pressure, and the magnitude of the hydrostatic force is the pressure at the depth of the centroid. So that's gamma concrete times y1 over 2 times the area of the plate. And we know that the distance between the center of pressure and the centroid of area is given by I bar divided by y bar A. So that's one of our ideas. Our second idea is if we draw a free body of the form, we can see that the hydrostatic force acts here. There's a reaction force and a moment at the base and a weight of the form, which we're going to neglect. So we can see from this that if we want to find the moment at the base, we simply take the hydrostatic force times its moment arm. And it's also useful to do a little geometry and figure out that the length of the form is 1.732 meters. Let's look at solving this problem with the Gini table. Step 1, we begin with an equation with our goal in it and build a table. So our goal is the moment at the base, and the only equation that involves our goal is the moment at the base is equal to the hydrostatic force times the moment arm. If we look at this equation, we don't know what the hydrostatic force is, we don't know what the moment arm is, so they both go in the needs column and we don't have any information. Step 2 is we identify a new goal and we make our next row of our Gini table and we cross out the variable that we've now added to our Gini table. Here's what that looks like. Our new goal is the hydrostatic force, so that goes in the goal column. We've written an equation for the hydrostatic force. So we've crossed it off now out of the needs. And now we look at the variables in this equation. Gamma concrete we know, we write over here. Y1 we know, we write down here. And the area is easily found and we write it right here. Okay, in step 3, there's only one more unknown, the moment arm, YB. So step 3 is identify the new goal and create a new Gini roll and cross out the needs column. So our new goal is YB, and here's an equation for it. This is the slant height down to the centroid of area. Then we subtract off the distance between the centroid of area, the center of pressure. So that's I over y bar A. And looking at this equation, we know what y bar is, we know what A is, but we don't know what I bar is. So it goes in the needs column and we cross out YB. So our new goal is how to find the area moment of inertia. So step 4, new goal, new row, cross out need. So we add a formula for the area moment of inertia, BH cubed over 12. We know what B is and we know what H is, and we add them over here to the information column. And there's nothing more in the needs column. So what you want to notice here is that all the variables in the needs column have gotten crossed out. And we can see that there are 4 variables we need to solve for. The problem goal plus 3 subsidiary goals. So closure, step 5, 4 equations, 4 unknowns. Now our next step is to find the easiest way to get numbers out.